Hi, everyone. I'm Kush Ganesh. Let me introduce myself. I've completed my MSc in cybersecurity, and right now I'm pursuing a PhD where my research is focused on applying artificial intelligence in cybersecurity. Before this, I worked as a cybersecurity analyst and trainer, worked on multiple testing on various domains, and training professionals in web, mobile, API, and IoT security testing. For understanding web application vulnerabilities in this presentation, we will explore what web applications are, why they are targeted by attackers, the common vulnerabilities they face, and practical ways to mitigate these risks. Whether you're a developer, an IT professional, or someone looking to enter cybersecurity, understanding these vulnerabilities is crucial in today's digital landscape. What is a web application? A web application is essentially a software program that runs on a web server and is accessed by users through a web browser over the internet or intranet. Think of e-commerce sites like Amazon, online banking portals, social networks such as Facebook, or SaaS tools like Google Docs or Office 365. These applications handle sensitive user data, process transactions, and often deal with confidential business information. Because of their critical role in our daily lives and business operations, web applications are attractive targets for attackers seeking to steal data, disrupt services, or exploit users. What are web application vulnerabilities? Web application vulnerabilities are weaknesses or flaws in an application's design, code, or configuration that attackers can exploit to gain unauthorized access or control. These vulnerabilities can result from improper input validation, where user input is not checked adequately, insecure authentication mechanisms, or misconfigurations in server and application settings. Understanding these vulnerabilities is crucial not only for security teams but also for developers, as secure coding practices can prevent these issues early in the software development lifecycle. Common web application vulnerabilities. In this section, we will look at the most common web application vulnerabilities that you must be aware of. 1. Injection attacks, like SQL injection or OS command injection, where attackers send malicious data to manipulate queries or commands. 2. Cross-site scripting, XSS, where malicious scripts are injected into trusted websites. 3. Cross-site request forgery, CSRF, which tricks users into performing unintended actions while authenticated. 4. Broken authentication and session management, due to weak mechanisms protecting user identities and sessions. 5. Security misconfigurations, like using default settings, open ports, and unpatched systems. 6. Sensitive data exposure, which occurs when confidential data is inadequately protected. Now, let's discuss each vulnerability in detail to understand their mechanisms, impacts, and prevention methods. Injection attacks. Injection attacks occur when untrusted data is sent to an interpreter as part of a command or query. A common example is SQL injection, where attackers insert malicious SQL statements into input fields, manipulating the database to view, modify, or delete data without authorization. For example, if a login form directly uses user input in its SQL query without validation, attackers can input SQL commands to bypass authentication or extract sensitive information. To prevent injection attacks, use parameterized queries or prepared statements to separate code from data. Implement proper input validation to filter unexpected or malicious input. Use object relational mappers, ORMs, which handle queries safely. Follow the least privilege principle for database users, ensuring applications only have access necessary for their function. Cross-site scripting, or XSS, occurs when attackers inject malicious scripts, usually JavaScript, into web pages viewed by other users. For example, a malicious script in a comment box on a website could run when others view that comment, stealing their cookies or session tokens, which can then be used to impersonate them. To prevent XSS, sanitize and escape all user input before rendering it in the browser. Implement a content security policy, CSP, to control what scripts can run on your web pages. Use secure frameworks that automatically escape output, reducing the chances of accidental injection. Cross-site request forgery, or CSRF, tricks an authenticated user into performing actions they did not intend while logged into a website. For instance, If a user is logged into their online banking and clicks on a malicious link, it may trigger an unauthorized fund transfer using their session without their consent. To prevent CSRF, use anti-CSRF tokens in forms and requests to verify the legitimacy of the request. Require re-authentication for sensitive actions like fund transfers. Set the same site attribute on cookies to restrict cross-origin requests. Broken authentication and session management. This vulnerability arises when applications fail to protect user authentication credentials and session identifiers adequately. Attackers can exploit weak password policies, poor session handling, or predictable session IDs to hijack user accounts and gain unauthorized access. To prevent these issues, enforce strong password policies with hashing. Implement multi-factor authentication, MFA, to add an extra layer of security. Ensure secure session handling with short timeouts, regeneration of session IDs on login, and secure cookie flags. Implement rate limiting on login attempts to prevent brute force attacks. Security misconfigurations are one of the most common vulnerabilities and can include asterisk using default credentials like admin/admin, having unnecessary services enabled, improper file and directory permissions, running unpatched software with known vulnerabilities, revealing sensitive data in error messages. To mitigate these risks, regularly update and harden your server and application configurations. Perform automated security scans to identify misconfigurations. Follow security best practices and compliance frameworks such as OWASP Top 10 and CIS benchmarks. Sensitive data exposure. Applications often handle sensitive information like credit card data, personal identification, or health records. If this data is not adequately protected, attackers can intercept or steal it, leading to severe privacy and financial consequences. This risk can occur during data transmission in transit or while data is stored at rest. To protect sensitive data, encrypt data in transit using HTTPS and TLS. Encrypt sensitive data at rest in databases and file systems. Implement strict access controls to limit data access to authorized users only. Regularly audit your data handling practices to ensure compliance and identify gaps. In conclusion, understanding and mitigating web application vulnerabilities is critical for protecting user data, preventing financial loss, and maintaining your organization's reputation. By prioritizing security throughout the development lifecycle, from design to deployment, and by following best practices like secure coding, regular updates, and thorough testing, we can significantly reduce the risk of web application attacks. Remember, security is not a one-time activity, but an ongoing process that must be embedded into your development and operational practices. Thank you for watching. If you found this video helpful, give it a like, leave a comment, and let me know whether you'd like the next video to cover a basic, intermediate, or advanced topic in cybersecurity. Don't forget to subscribe to Cybernetlearners and hit the bell icon so you won't miss any updates. Your feedback helps me improve and bring more valuable content your way. See you in the next video.